Hello, everyone.
We're back.
Yeah,
It's been a while. Hey, Brian. Good morning.
Morning or good
so
evening for you.
actually, good afternoon.
Afternoon business.
Yeah. So, lot of time zones here, I think. And yeah, we are back to our normal schedule. So, Wednesday, 16 CEST, summertime in Europe. And today we have an interesting topic, I think. I think the front end topics were always kind of interesting and well running on the stream, so I think we will have that today again. And we wanted to talk with a recurring guest, Brian Finster, about this topic because he's now a front end engineer. And
I'm a generalist. I do whatever's required.
What,
exactly.
I'm worried to ask what legacy mess you inherited on the front end.
So
Like
we will
what
hear about
what
that.
UI is there to test on a submarine?
I mean, this isn't for a submarine, but
Okay, no, a hashtag submarine. Can you introduce yourself a little bit? Who you are, what you have done at Walmart, and why you are now working inside a submarine sometimes?
well, I actually don't have a clearance, so I can't get on a submarine. But I'm Brian Finster. I've been a software engineer for a while, a minute or two. Yeah, and in Walmart, I worked in logistics and for many years. And then I started working on the logistics of software delivery, started really focusing on continuous delivery. We were using that as an improvement strategy at Walmart, and ultimately led to me being told to start a dojo so I could help other teams, build a team to help teams learn how to do CD. Later moved to work for Defense Unicorns, where we're trying to help the Department of Defense for the U.S. Deliver software better and faster and more secure, and deliver at the speed of relevance. So that's what I do now, and yeah, I'm working on actually right now. What I'm working on is refreshing our websites. We got a small team that's now dedicated to front end development. And I was asked to kick that team off so we can get our websites whipped into shape. So it's just straight up web development right now. But I've been.
Is it your first time web development, front end web development?
No. I mean, so first, I used to be a full stack developer when I started, but the full stack was, the front end was 80 by 24 green screen. So, but I mean, there's a lot of design to making an 80 by 24 green screen that's got a lot of content in it that's usable, and getting a good user experience out of that's challenging.
Yeah.
But no, I've done, some, let's see, we started using Angular when it first came out. And I did a little bit of Angular, not much. I was really focusing on the server side, on the team, and we started using that. And then
would you say Defense Unicorns and the challenges you're facing are more enterprisey in nature, or do you want, move quickly and sort of adopt this sort of lean thinking more?
As far as what I'm currently working on, or just in general?
Let's say right now, your current context.
I mean, anytime you're building something, so the only context I have is we're building things for large enterprise, and I always work that way. And I want to have a good solid test suite. I want to be able to make changes without fear. I just have those habits, and it irritates me when I can't. And so, the high priority for me is always to make sure we have a test suite in place so that I can move quickly and not be afraid. Especially when you're dealing with something like company websites, where that is that's the point, that's what people see. I mean, that's your appeal, your front door. You don't want that screwed up because it makes you look bad. If it's an internal application, you can get away with a little bit more than if it's an external customer facing thing.
That's all. That's the point in front end in general. I think that. So what is the actual difference between front end and back end? Of course, the architectures and stuff like that. But the main aspect when you are in a real work environment is always that the front end is really focused by users, by product owners, by all stakeholders. All are focusing on the front end part. No one cares too much about the back end as long as it works somehow. And so in product, especially product managers, product owners, they always look at the front end to determine if a feature is done or not. It is less likely that they have something like Postman and start to test those things. That's actually sometimes the case as well. But front end is just typically this this thing everyone is watching or taking a look at it.
To be fair, one of my biggest pet peeves is when somebody is building a service and they build an API for that service that really, really sucks. I mean, you really need to focus on the user experience when you're talking about APIs as well, because a bad user experience in the API causes errors. Bad user experience in the front end causes errors, and really need to focus on
it's holistic.
You need good design for the user experience on both. But no, I've done some web development as part of my job since 2015. It's just not my joy.
Adrian, you're the most front-end savvy here. What have you been up to lately, and where can people find you?
Well, the link you just displayed, actually. So yeah, front-end service. So I would say that my job is to be a CTO and entrepreneur. This is what I am mainly. And when it comes to engineering, front-end is what I actually thrive in. So I do that to a degree where I can say I love that type of working, right? So I started as full stack as well, so I could work in the backend area as well, but it's to drive for me. So it is so boring that I'm a little bit of this entrepreneurial person who needs to love what I do, right? In order to overcome, discipline problems and stuff like that. And front end is where I actually shine, I would say, as an engineer. And when I'm thinking of front end, this is one of the reason for the topic today actually is I think that front end evolved a lot. So I would say, let's say 10, 15 years ago, when we started still to work in front end area with something like Prototype.js and Internet Explorer 6 was still a thing, and front end wasn't a known discipline or a unique discipline back then. It was something the full stack engineer, backend engineer had to do, and we were pretty early on in actually saying, okay, we build an entire front end in JavaScript. That wasn't common back then. 15 years ago, it was definitely not common. It was normal that you have your typical PHP site and this, have in the payload somewhere some HTML, JavaScript, and CSS somehow, right? And it was tightly connected, extremely tightly connected to the backend code.
Having JavaScript was considered a luxury that only like high-paying clients would go for.
Exactly.
To have dynamic content.
And this was the reason why we used Prototype.js, where we had memed classes.
And jQuery, yeah. Ultimately, jQuery
we
was
never
the
used jQuery, but we never used it because I never liked it. And jQuery was a different approach. So actually what we know from today, we already built back then. And other company ask us why we're doing that way. That looks stupid to have, a front end is not in discipline like that. But it changed pretty rapidly. Later when then Angular were there and those kind of things. Today, of course, React. Front end is a known discipline of engineering. It is, of course, the same. So, for example, I be working in our company in a tech stack where we basically do everything in TypeScript, front end and back end. So Next.js and Nest.js, the frameworks, and React and TypeScript. And that feels pretty good, I have to say. And the front end part is so interesting because I'm talking about PWAs a lot. So you think way more, instead of just building a website, you think way more in building the actual client. So what you know from the client development back then, when you compile a client and ship the client, you actually do today in modern front end development as well. So the two worlds of the typical web designer who back then did those web designs in things like Dreamweaver, where Adobe Suite stuff, or even Flash or something like that. Today you have that more streamlined or more in the engineering space again, where you can apply things like continuous delivery, DevOps, even test-driven development is now possible in in the front-end space. And this is what I really love. So when I put my hands on the keyboard in an IDE, it's basically exactly that. And my special thing is actually to repair legacy front-end systems and to bring them up to speed again. So,
but to be fair, things like TDD on the front end have been possible since, the first time I got my hands on Angular. Angular was actually my first experience with modern front-end development. I mean, I'd taken some classes, but I didn't actually have to do it for a job. And Angular 1 was my first exposure to, oh yeah, we're actually going to use this for something real we're building. I'll tell you one of my biggest pet peeves, though, especially as a mostly back-end developer who can do front-end when required, right, is that when I hear back-end developers tell me how easy front-end development is. The other pet peeve I have is when I have front-end developers tell me it's a waste of time to test it. And considering the the issues I've had recently, where we've made we're trying to refactor these websites that were created externally and we're bringing internal. The issues I've had with regression because of coupling, because the original design was tightly coupled, where you have a change in one part of the system would cause cascading change somewhere else. And we're trying to rip that apart so we don't have this. We have something a little bit more modular, easier to control. But to have people tell me, it's pointless to test it. There's behavior on the front end. If you have a front end that does not have any behavior, then you don't need to test it. Just to demonstrate to me a front end with no behavior, then you don't have to test it. So I get irritated by both of those groups.
Yeah, but this is one of those points where when you combine those two aspects of that, we're going more and more in the application area. Then you have a lot of behavior there, which means there is behavior, dedicated to the front end, behavior dedicated to APIs, even services on the API side. And the API in between is just an API. So it was back then, 15 years ago, it was different when you have everything packed in some weird monolith thing. But today it's different. So you need to make sure that if you change something, and of course, if you start an app just as a website, it seems that that's so easy, but you always need to consider that your app will grow. So software is a living thing. It is nothing you build once, like in real estate thing, right? You build a building and you wait 15 years before you do renovations. You don't do that like that in software. It's basically ongoing. Refactoring needs to be ongoing. And if that is not possible because you don't have tests, you will, after 1 year, you will suffer from that. And this is what when I said I doing those things where I repair those things, this is the reason why I'm basically talking about that. It is exactly that. So many companies out there have this exact problem. So many teams working on a code base which is constantly broken because you change something and something different is simply not working anymore. And 2 days later, the clients tell you. And then the stress is big. So instead of focusing on the new features to come and refactor it properly, you just fix things and you don't know about those things. So it means that you think you start on Monday, working on Monday, right? And instead of basically working on the next tickets, on the next features which will bring you value, you work on the next task which is coming in, which is actually a bug fix no one was able to see. But if you would be able to move that into the CI/CD pipeline and make sure you don't deploy those broken things, at least let's say 95 or 99% rate that you basically catch them before they go into production, then you can start to focus on those things. And this is this is actually not just reducing stress overall. It is something which creates a better working environment. You start to go to work as a happy person and not as a totally depressed person because you need to fix the next thing and you don't know what it is. And front end, and people consider it often as it's just a website. But front end is way more today than just a website. Just take a look at the average project after 6 to 12 months. They are huge. Huge. It is. There are so many conversations about what type of boilerplate do you need, but this doesn't matter. The custom code you write, no matter in which language, no matter in which framework, is huge after 6 to 12 months. And every team, or we help with our own teams, it is always about, let's say, a ratio between at least 2-to-1, 2 front-end engineers, 1 back-end engineer, and sometimes even 3-to-1, because there is so much work on the front-end to do, and actually not so much on the back-end in comparison. Because back-end is, let's say, a homogenized environment, while front-end is, hey, Wild West, right? So you need way more manpower, and actually to get things done there in a good way, if you want to do that properly. And this is simply my experience there. So front-end is a discipline. Sorry.
The challenge I have, and one of the things I'm hoping that the audience can help me with is, again, I'm primarily a back-end engineer, and I think front-end testing is so much harder than back-end testing. It could be just inexperience on my part, but I think it's just really, really hard because I can test for behavior on the front end and then have the CSS stab me in the back. How do you test that you don't have things like div overruns, that you don't have, or overflows, that when you put the image where you want it to be, that it's actually where you want it to be instead of just somewhere in the DOM, right? Oh yeah, it appeared and it's there. Cool. And I can assert different things on it, but I can't say it looks right. And I've been looking into visual testing tools so I can see when there's unexpected change. But even then, I have to go and look and see if there's unexpected change as part of code review instead of just having the pipeline break. I want my pipeline to break because something changed that I didn't expect it to in the way it looks, not just in the way it behaves. And I don't know how to do that. So maybe somebody has a solution for me, because I really want the joy of back-end pipelines on the front end is what I want.
You had a tool last time we talked. What was it again? I forgot.
Chromatic. So, and Chromatic has a free tier and a paid tier. And for what I'm working on, we could probably use the free tier. It's got to go through security review before I can use it. But it's a tool that will actually highlight visual diffs on pages. And so if you have a page you expect it to change, oh yeah, I expect that, and you can just approve that, and you can code review what it looks like, and so you just make that part of your code review process. And if it's unapproved, it's like, oh well, crap, I need to fix that. We didn't expect that. But I really want just the pipeline to break. That's what I really want.
Okay, Dennis, what is your opinion? You were silent so far.
I'm slightly triggered by your microphone problem, so I'm trying to figure out how to boost you in the background while we talk.
We had a problem last time.
No, but it's okay. But I know, knowing you'll be unhappy editing after the show, and I know you take these things very seriously, and I got a feeling you wouldn't be happy about it.
All good. It will even out that stuff. So it's a problem actually with StreamYard. So in all other devices, I am too loud. So StreamYard is very strange when it comes. I don't know what it actually is.
Okay. Because we had a comment. We had somebody comment on chat about audio. We can post. Let's assume we'll fix it in post, and let's give it a good shot. Just give us some feedback in chat if
I can't change anything right now. So
yeah, fair.
So go ahead, Dennis. You can answer.
Yeah. So I've been actively. So what I've been noticing. So I am coming from my first job ever was working at a very prestigious corporate branding agency. We had an art director. We didn't have a UX designer. This was in 2008, 2006. We have an art director, and somebody who takes paper print, pixel perfect art and color balance extremely seriously. And this was in the era of IE5, IE5.5, IE6. Firefox, it was still Mozilla, the Mozilla browser. Firefox didn't exist back then. We had Netscape and Opera and discussions about whether to support Opera mobile. So I started my career in a world where people would obsess about these things, but they would never measure ROI on it, right? So it was very difficult to say, well, what's the ROI on your branding power? They weren't able to express that. They were able to express this dissatisfaction with misalignment with their brand, right? So they could measure it, they could see it, but not in a way that could be expressed easily to a computer.
Mm-hmm.
Nowadays, that's much easier, right? So nowadays, you could have AIs that are RAG assisted and ask, "Hey, does this website represent the Coca-Cola brand correctly?" Right? You can have a conversation like that, and you can introduce that into your testing pipeline. It's like, "Hey, okay, smoke tests are fine, unit tests are fine, integration tests are fine. Launch it. Does it follow the brand specs? You as somebody who knows this brand, would you recognize this? Is there anything obviously wrong with it? Mm-hmm. Is there anything critically standing out?" You could use LLMs for that because they're very good at fuzzy logic, right? So UIs always have that fuzzy logic, and the trick with UIs is that UIs never run in a user interfaces on the web. I have to preface. And this has been my experience. I've been in the industry for almost 20 years now. And my experience has always been that we underestimate the integration problems with UIs. Because our UI as code, it never runs in a unit test environment, right? So there isn't my backend server is production, right? It is always a foreign system, right? So I don't exactly know what browser it will run under when it's deployed to the user's machine, which means that there is no baseline operation. Everything is exotic to the degree that I need browser vendors to give me some freaking guarantees to tell me what I can even test and what I can even assume about these browsers. Because there are two moving planes in the UI space. My code can work correctly, but maybe an engineer has made a regression and now the next version doesn't look as nice anymore. That's one area. The second area is there were no changes in my code, but the freaking browser changed. And now the same code is rendering differently in the new version of the browser.
Yeah, let me give a concrete example. First, I want to somebody commented about snapshot testing in React, and I'm Svelte right now. You can also do snapshot testing in Svelte because you can test with Jest, but the problem is that the things that I'm trying to test for aren't the components missing or it's moved. I'm trying to see the component still looks the same that it should. And if you, as a concrete example, if you go to zarf.dev, so Zarf is one of our open source tools, and zarf.dev has these moving ZARF, right? And it's a really cool tool. You can bundle up an entire Kubernetes environment and create a version OCI package that can convert that entire environment to an air-gapped, water-gapped, or just I want this repeatable environment. Anyway, but if you go to zarf.dev, there's these moving blobs. Okay, I can test that those blobs exist in the DOM, and I can test that they're where they should be. But to test that they're not causing div overflows, that they're responsive to the various screen sizes, all that sort of thing.
Yeah, makes sense.
Very difficult. You can't do that with a straight up just snapshot. But well, hang on. But you were talking about and then I lost what you were talking about. Oh no. So I almost had it. Damn it.
Regression because the developer made a mistake or because the browser is changing the ecosystem?
Oh, yes. This is the other thing is that we use, Figma for designing what everything should look like. Our designer puts a lot of effort into it should look exactly like this. And then we go and build it. And Figma is really cool. You can extract CSS, although we're using Tailwind now because we had problems with cross-browser compatibility, so we started using Tailwind to try to minimize that.
I have so much to rant about the Tailwind.
Yeah, so you extract the Tailwind, so Figma will produce the Tailwind classes for you. And then you go apply the Tailwind classes, and it looks different in Chrome and Firefox and
of course it does.
Safari than it does in Figma. And then we had a thing where one of our menus was behaving incorrectly on Chrome, but it worked great on my phone, like our mobile menu. So it worked great on my phone. I tested my phone, I tested my iPad, everything's fine because I'm Apple everything because I'm lazy. But as soon as you pull it up on Chrome, it doesn't work. And of course, I have no way of testing that because I don't have an Android device lying around. Yeah. And it's these sorts of problems. To your point, it's like you can't get your hands on the environment unless you spend all the money to get your hands on the environment. I know that platform at Walmart, when we were spending a lot of effort providing testing platform tools for mobile for all the teams doing mobile, so you can go and just deploy to an array of devices and verify I was working on an array of different devices.
After that branding agency, I worked for a few years in ad tech in like a huge transnational advertising network, and we had the same problems, right? So how do we make sure that all the ads, all the formats of ads, all the different capabilities of all the different ads, we had video ads, banner ads, text ads, audio ads, like in-stream ads. How do we verify that all of them work on all devices, on all machines, in all browsers?
We need front-end containers. I need to be able to just deploy a container, and when you
need hardware containers. I know we were leasing a service where they would have physical phones hooked up in like a robot.
No. That's what I mean. Now, what I want is I want a container so I can deploy the front-end container.
Yeah, I would like a container as well.
You use my browser engine and not your browser engine.
Yeah. The issue is how realistic of an environment is that compared to the actual device?
No.
Sounds like WASM.
I'm not talking about for testing. I'm talking about for production. I want to be able to deploy a container, and then when you open the website, you don't open it in your browser's engine. You open the container and use the browser engine that I deployed to production. That's what
this is the WebAssembly. That would be possible in WebAssembly, actually. But let's say I saw sites being done in those, and you really see that they have a hard time really doing nice UI. So CSS is pretty good in terms of how to express UIs, animations, kerning, all this kind of stuff is actually quite great. But it is you have those differences. But I would like to ask to add something to that because I struggle with those things for so many years right now. And in the last product, so we just released the first version of CloudBar, which is a SaaS platform product, and it does have a typical UI. For the front-end part, it does have an admin UI as well. Both are created in React and Tailwind as well. So it's not so much about Tailwind, but what I was in the stream about Tailwind, I was talking about the upper ceiling of complexity, which means that one of those things which is very important in the front-end to understand is try to not over-engineer. So it is a little bit of engineering, especially when you say about talk about over-engineering, under-engineering, it's about quality. So you need to define requirements and qualities up front. Try to reduce them to the least necessary thing. So the more you pack into, let's say fanciness into your requirements, the more you will suffer. Now, so you basically build in new problems with low value. So it is like all the animations, all those very special things, let's say 5 breakpoints on your website. And so let's say so many components built yourself or, with so many specific states in those things. Try to reduce that and this is the best advice I can give you, because if you reduce first of all the requirements and then use just what you really need to get to the requirements, you will see that you won't have those problems. So in 1 year of development, a fully fledged application which is made for at least enterprise level companies, we just have one of those glitches reported. One it was basically a little drop down with a glitch that it's not working in Safari right now, and that was easily fixed, and that was a stupid mistake done. I don't know, maybe by me, but the point is the rest of the application is looking nice. People love to use it. It is simply made. Still a little bit of animation inside there, but none of those problems recorded. And the reason is to reduce everything and not saying, hey, I am great at this. I'm doing that in such a special way, and taking too much care about the semantics and all this kind of stuff. Sometimes it's easier to just try to keep it as simple as possible in front end. And then it becomes easier to test and easier to predict the outcome. That's actually very important, prediction in this case.
Well, this is something else that I think is super important when it comes to front end design. It's almost the same as back end. Mm-hmm. Yes, I mean, you have the styling that can make things look different, but the same principles apply. And if I'm doing back-end development, I don't write giant functions or giant classes. Mm-hmm. I do a whole bunch of things. I use functional composition. I have very simple. So I'm not going to make a card with an image and text and a button and make that all one thing. Those are all going to be separate components. I'm going to use functional composition on that, so I can reuse those components and test them individually simply, and then also test that they work together. And and make sure that so there's onion architecture is something that you should look at as well, is that the thing inside shouldn't know about the things outside, right? You inject components, you don't have the components know about things. You don't, I think it's a really bad idea to have a component know what the external container looks like and try to adjust itself to meet the external container. An external container should control internal containers, right? I mean, it's the same sort of design principles you have on the back end.
Yeah. And that's very same for one of those reasons why this has vastly improved with component-driven front-end design, where you reduce connaissance of distance between or position. The distance? I forgot. Distance, right? Between the actual HTML markup and the styles, because
and with the help of design systems, you can increase cohesion of code that is purely cosmetic and separate them from code that is logical. Because in the UI, that's the biggest, that's the toughest challenge.
Yeah,
your
problem...
HTML and your JavaScript and your CSS is way too close to each other, but they're always separate. So then it's very difficult to express. Usually it has an ID or a class, but now I can't judge distance. It's like, okay, it has an ID. Was that for logic or was that for nothing? Was that for the hyperlink? Because it's an article. And
design should not be logic, and this exactly. You go into the direction already, and this is one of the polarizing things when people talk about things like vanilla CSS versus Tailwind, for example, where you have different approaches to do things. So cascading, for example, right? Cascading is an interesting idea, but actually causes so many problems that it's. I personally don't see the big need of cascading anymore. I try to avoid cascading because that was one of those reasons why we had problems in the past, and don't have those anymore.
It's like building a whole bunch of small services and having them all talk to the same schema. Right?
It doesn't make sense, right? Yeah.
Coupled with the database, coupled with the style sheet. It's like, how do we reduce the coupling so that we can?
The issue is,
but don't CS variables.
Oh, sorry.
I was going to say it's the same as having global variables. I mean, you don't want. I mean, yes, there are use cases for some global variables, but they're small. Why would you have a style sheet as your global variable for everything?
But it's not the developers who build the style sheet or the ecosystems that sort of facilitate needing the style sheet. The issue is more on the spec side. See, the CSS as a spec, as a language, did not keep up with the improvement in technology. With the
No, it's
improvement in
terrible.
technology.
It's
It's
awful.
terrible. It's still stuck in 98.
Yeah.
In 1998, and it's still treating the web as a assortment of
It's a big
documents.
document. This is the big problem.
It's
So
not LaTeX anymore. Like,
How do
we've
I
moved on.
How do I assert styles? Now, with Tailwind, I can at least assert the classes.
And that's the point. Tailwind is sort of becoming that spec that CSS should be, right? So it's giving me this idea of, this is a button that I know will be inside a container, so I want it to flex a certain way, right? So that is what the language should have been capable of doing without me fiddling with classes. But I can't. So there's a framework that does the class fiddling, and you can just express what you actually want it to do, right? So there is an expression of behavior, or there's an expression of, let's say, more nuanced, like qualitative properties, visual properties that an element might have, or a group of elements might have, or just a relationship between elements might have, on the technology side. And that's what Tailwind is solving. But as an artifact that people hate, it produces sometimes, like CSS class vomit. It's like,
I mean, it's very verbose, and I'll tell you,
very verbose.
The pragmatic reason we switched from where we were, which was we had all these websites with CSS and converted everything to Tailwind, was because we made all these changes that we're very excited about, that updated a whole bunch of stuff, and it worked great until somebody opened it up in Firefox. And that didn't work at all, right? And so we immediately switched everything over to Tailwind, so we didn't have to worry about cross.
And there's so many hacks, like CSS locality, precedence of the selector, and then the more you become an expert in CSS and you start using those gimmicks, the more you increase the ceiling of complexity, and things can go wrong.
Exactly, it is like it is a little bit like working in frameworks, right? If you have worked well in a Tailwind project before and you switch to another team, it is easy to keep up, because the idea of Tailwind is, if you take a look at the component, then there is not much influencing this component from what I can't see right now. And this is the biggest fears when you are in a CSS environment. Of course, they are BEM as well, for example, block entity modifier, block element modifier patterns as well, where you try to do that, but still it is in a separate file, which I don't understand, because again you have this connaissance of distance in this case. And it doesn't help you, because all the problems we were just talking so far are based on that you cannot see what's actually going on, and you want to reduce the complexity and the possible problems to a level where you can actually start to focus again on what you want to do, instead of fiddling out all the problems. So if you reduce it down, you of course reduce the possible problems down, which makes it more deterministic in terms of testing.
So this is going to be a tangent, so bear with me. One of the best UI testing technologies in general happened in AAA gaming, in the first-person shooter world. See, because they have similar problems. So, and the most recent changes to this were Doom Eternal and CSGO. They had two different problems. Doom Eternal was this extremely accessible but extremely fast-paced shooter. Have you played Doom Eternal or CSGO? Any of you?
CSGO, okay. Yeah, but Doom Eternal.
So there's two problems in each game.
I had to give up first-person shooters because I got addicted to sniping people.
So there's two problems that they had to deal with, and which was an extremely difficult technology problem. Doom Eternal had to not jitter on FPS. It had to be constantly smooth. So it became commercially successful because it ran exactly at the same FPS on all hardware. It didn't look the same, but it felt the same. And the FPS never jumped. What it did do is that it constantly reduced or increased the resolution depending on how much gibs are on the screen. You're just killing demons, and the busier it gets, the more it downscales. But when you're adrenaline packed and you're in the thick of it,
Don't see that.
you don't see that. And eliciting that emotion was extremely powerful to get that right. Not a lot of companies did that, to say, when it matters, we'll just make the graphics uglier, because that's what the users want. But then when they have a moment to take in the scenery, and there's no monsters on screen, and there's music in the background, sure, they can enjoy it. Right? So they got the balance right. Rather than always forcing the same level of quality, then you look around at the vista, and it's like... And then I look down at the floor, and it's 4,000 FPS. And I don't need that. I don't need those two extremes as a gamer. Now, what was the key ingredient there for the front end? Back pressure. I needed to know whether a 15 millisecond reflex could be done by the player in 15 milliseconds. So when it couldn't, the game engine immediately back pressured, but not from the game loop, from the render. When the game loop slowed down, it immediately back pressured to the render, saying, no cool, we gotta go down. The game is not keeping up. And if you played games like Satisfactory, which is also a factory building game, but it's built in a AAA shooting engine, it's basically like building a giant website. It's just a factory game. Like, it's a logistics simulation, and it's an incremental game, so it's always more. So the longer you play, the more the freaking FPS tanks, right? And they haven't solved this problem. So what is the major complaint? Game is pretty fun to play, but the longer I play it, the more my PC hates me. Same thing with large UI related web projects. The older it gets, the more I hate my computer for having to run this. So that's one side. Back pressure, right? So rendering back pressure to the logical component. That is a very key property that not a lot of big AAA gaming studios take seriously. Its software possibly the most aggressive on this front. Now, there's a second element. Smokes in CSGO. So CSGO is terrorists versus counter-terrorists. Long story short, there's a grenade that puts a smoke on the screen. Now, that smoke is a very important tactical component to the game. Now, what's really important is that when the smoke pops, regardless of your graphics settings, you're not allowed to see through the fucking smoke. Because if you can see through the smoke, everybody will start gaming the system and change their graphics settings to the point where, the smoke is a little bit smaller if I run it on high resolution, low shadow, and then everybody starts gaming that, and then all the professional gamers start doing that, and the esports televised streams start looking like poop, and then people can't make money off of graphics card sponsorships because nobody's running the game at high quality, because gamers are then incentivized to run at low quality. So what was really important is that the smoke had to be exactly perfect and behave the same on a low spec system as it is on a high spec system. And it took a few decades to get that right from all the different iterations. Same problem. There had to be back pressure in how the render affects gameplay, right? And I think that's from in a world, and tangent is now over. Thank you. So bringing this metaphor now to the software engineering space, what's the main issue? We have front-end engineering separate from back-end engineering, but our front-end needs to put back pressure when it's not rendering correctly. There needs to be some functional component reacting to that. And if we can't do that, then we need to guarantee that it doesn't happen. But that doesn't mean that testing is the only way. You can also say, hey, the user is supposed to continue the workflow, but the button is not visible.
So I've got two concrete examples of that. One is very, very basic, right? If you're waiting on a service to do something, you've got a spinner, you have something, and the speed of that spinner has an emotional impact on people.
Yeah.
And trying to find the right speed for that spinner to have to make it so that they're not so frustrated.
And the noise in the background and the visuals, so it doesn't look frozen, but also it doesn't look endless.
But also, how do you get that faster feedback? So the the very first time I ever had to use modern web tooling, again, was Angular 1. It was, by the way, Angular 1 was terrible.
Yeah, it was terrible. I think we can all agree that it was terrible. The API was not very good.
I'm going to give you 5 different ways to do the same thing because we couldn't agree at Google. It's just terrible. But anyway, so we're building it's all HTML, but it's designed to run on an Android device in a distribution center to do receiving. And to get item information required us to go and make 8 different API calls to different systems to collect all the item information together so that you could receive that item. And for me, the thing that I worry most about as a developer who is trying to help people do their job is how to make them not stand around waiting. I mean, I hate waiting. I know they hate waiting. As a value stream architect, I know the cost of wait time. Even then, it's just like, on a green screen, it was really fast because we had this giant monolithic, terrible system that was hard to maintain. But at least the information was really fast. But here I had to make 4 API calls and collect all this information, and I didn't want them looking at spinners. I didn't want to spend all my time figuring out how fast to make a spinner, right? So what did we do? We created a service that all it did was cache as much information locally as we possibly could based on what's going to happen, so we could have one API call for a small local cache that and also gave us resiliency. So if one of those services went down, we didn't just say, oh, sorry, you can't receive. We had cached information that would help them for the next few hours just in case for resiliency. And this is something that...
It's a good example of edge computing, right? So you're compartmentalizing locality in a way that is meaningful to service integration.
Well, but this is why it's, I think a bad idea to have a front-end team and a back-end team. You have a product team that handles both. Or if they can't, if it's too big to be one team, you at least are working constantly on these problems. How do I have a good user experience?
When you have a back-end team,
you care about user experience too. And if you don't, you're just not being you're not a good back-end developer.
When you have a back-end team and a front-end team separate, it's not always clear whose problem the integration concerns are. And that's one of the biggest challenges there, right? So it's like, when I talked about earlier in the games and about this back pressure problem, it should be immediately clear whose problem it is. It's the problem of the person who designed the game to be fast-paced. Or it's the problem of the person who designed the smoke to be an important tactical piece of the game loop, right? If it was benign and unimportant, nobody would care. But it's that game designer's decision that the engineers around that person need to make sure that that's always stable. Because the engine designer won't understand that this is important. The person doing stuff in Figma won't understand that there is a level of finesse necessary to make this certain type of gradient shadow render the same way in 7 different browsers. Right? So,
and I think we started very early with those, design flaws, and then you don't get it pixel perfect in every browser. And I think this is not the biggest issue with frontends these days. Frontends, there is these expectations, which we just discussed right now, which is that people have expectations. So people have expectations that something is going immediately to your screen, right? So first render is something you can work with, and even if there is something which takes longer, you must package it in a way that you accept it on a personal level. So the emotional part of the definition of done of a feature must be a good user experience, satisfied user in this case. So how do you do that? And I know that, so we have that as well. There is a lot of discussion going on how to improve it from the backend services, from the scale of those, from the Redis caching, from the caching on the client. You can cache on the client a lot with a service worker as well. You can cache things into local storage or IndexedDB, especially when you have massive loads of data, right? So sometimes you have those systems where you have contracts, datas, orders, thousands of them, which needs to be transferred to the client. This is this is a challenge actually to get that right in that moment. And sometimes, and I know systems, we work on ourselves, this is an ongoing thing. So you don't optimize that in a half an hour before going live. This is ongoing. This is on some point you reach the next level where you have more of those things. Then you add more complexity. Suddenly it works. It doesn't work anymore. People need to wait. It's not working on a specific phone device anymore because there are limitations in Safari, how much you can store, stuff like that. Those things you need to understand these days in Frontend in order to create a great experience in terms of an app on all devices. So of course, a website is a little bit more simple than that because you are focused on extremely fast loading rates, SEO, what Lighthouse tell you. This is the big thing. But in either of those cases, you are constantly optimizing things. And that's the reason why things like refactoring or being able to refactor are so important, because optimizations can often break systems, and especially in the front-end area. And to make sure that you can do that in an ongoing way, you need to have those tests in place. You need to have this confidence to work on that, like in the backend area, where you are happy to change a schema, and you see CI/CD pipeline is green, you are good to go. You don't need to test for 3 hours before going live with that in 2 weeks. And this is the very same on the front end as well.
Yeah, I mean, this has been my life for the last couple of months. As we've been focusing on this, is that I want to improve SEO. That's relatively easy, but I want to improve Lighthouse scores, want to improve my performance scores. Mm-hmm. Well, I'm now, I have to go out and refactor code. And if I don't have the tests in place, which I didn't at the time because we had an untested system that we had to go in and improve. So we're trying to add tests and fix things at the same time with some intense time pressures because we had some hard troubles because of the calendar is a real thing. Guys, there's things that happen that the calendar matters, and cause regression. Suddenly things are breaking and we don't know because in some cases it's a simple web page. You could look at a couple pages, but if it's not a simple web page, you can sit there and
it's very difficult to
and look to make sure every single thing is still lined up exactly. I mean, this is terrible. You need good tests for this.
Yeah, we used to redesign the main home pages, the branding pages of government agencies, of the capital of Ljubljana, and it's thousands upon thousands, hundreds of people editing content in their little ecosystems. Everybody has their own jurisdiction for content and data and representation, and then there's 200 content people managing a large website, and it's impossible to test everything. But there needs to be.
I'm sorry, go ahead.
So it's impossible to test everything, and it's also impossible to cover everything automatically. So it's really important to be able to separate out the design system from the content and the expectations of the system from some kind of emotional impact, right? So it's very easy to say, here's a test for emotional impact. Just run this one test, on every single site in the website. That's a good test. What's not a good test is saying this link needs to look like this. This one needs to look like this. This one needs to look like this.
Yeah, it's so much easier to write super fragile tests on the front end than it is. I mean, you can just say, hey, we're going to make tests that are nice, robust. That
and I add a menu item and everything breaks.
Yeah, I want to talk about Blaze's comment though here. There's one of the. I was talking to a friend of mine who was working at U.S. Bank at the time, and they were talking. This is when we were talking about transforming enterprises, and the way that U.S. Bank was doing enterprise transformations. They had something called the Design Studio, where the Design Studio they would keep bringing in new teams that were going to change the way they were working. But it became design first instead of just here's a bunch of requirements. And one of the things we talked about was that they were building a new mobile app for US Bank. And the way that they did the mobile app was they drew the mobile app with pencil on paper, and they had real customers come in and pretend to use it.
Not a big fan.
And well, no, but they were able to extract, information from that, so they could have a better design instead of building something, and then finding out it was wrong. Finding out it's hard to use, because they could get that immediate. And comes back to fast feedback loops. And yeah, absolutely, starting with the front end and then getting more and more information in the front end, and then using that to develop behavior tests that need to happen, not only front end but also back end, is just a very efficient workflow to get things done. Let's draw the front end, let's play with it. If we need to start bringing it in to sketch it out in more detail with a tool, sure. But I mean, even if you're just using PowerPoint and then just pretending to play with it and seeing what it feels like, it's so much easier to say, here's a bunch of requirements to go build front end, back end at the same time, and hopefully it all works. Because we'll build more than we need to, or less than we need to, or it just won't integrate well. Start with the front end and start diving through the stack.
Is it actually the opposite of the API first approach?
Well, the API first approach is, once I know what the behavior should be for that service, I need to start with a contract and work my way in. It's the same exact approach. It's just at a higher level.
I spend a lot of time in the modeling community. So event modeling, event storming community, domain-driven design, facilitators.
Yeah.
And sort of one of the biggest trends lately in the last 5 years has been sort of focusing on what are the important data transformations which are immediately connected to a UI element that is user-facing. Right? So to really start modeling from that perspective. It's like, what are the integration points with the UI? What data transformations does the UI facilitate?
Yep.
Because those have the most volatile APIs, and those have the highest sensitivity to amount of requests, delay on the request, chattiness on the API. So those have to be modeled first. You can still have a pretty API done with Swagger and sort of pre-planned everything by an architect, but it's really important to put the user-facing part of the APIs, maybe that's also federated with something like GraphQL, but to really put it into the hands of the product team who's designing it, not front-end engineers. Right? So it shouldn't be nerds talking to other nerds. It should be at least the integration side where the data has to touch the user being able to transform the data. That should be with a product engineering team that has good product leadership. Like that has been the biggest trend that I see in the modeling community. It's like, okay, who's designing this workflow? Not what technology are we using for the UI, but who's designing this workflow? Because the requirement for, if you were to write a automated test suite for the front end for YouTube, one of the tests would be our logo is always red. Our logo is always accessible by 2 clicks at most from all pages. And the user should be able to reach the settings page and log out with 3 clicks at most. Those are good tests. Because then wherever the thing is, I know that, okay, if it took me one simulated click and another simulated click and a third and a fourth, that test will fail. Because somebody had to rewrite the heuristic for getting to the settings page. And then there's a test that says, oh, it fails if it's more than 4 clicks. And they can't get around that. They can't unsimulate one of the clicks, right? So that is then a very good behavioral test for the design system. The problem is I have yet to see that being a norm in anything other than extremely high-performing teams, right? So it's very difficult to get that kind of culture across in a software engineering team, and to even get the non-technical part of product engineering, of product leadership, to be thinking in those terms.
And
there isn't any medium.
Rage King, this is a good segue into Rage King's question, is how can you identify a competent front-end dev?
It's Hugh, we had Hugh on a few episodes ago.
Yeah, I think it's similar to how you can identify a competent backend dev with one additional thing that means that I would not qualify myself as a competent front-end dev. Is because when we deploy a change and the designer says, oh, this is slightly out of alignment, And I mean, I talked to Adrian about this before. It's like I would have to hold up a sheet of paper, or color the div, or put it in inspection mode and look at the padding to see it. He can just see it. I can't see it. It's like, yeah, it looks fine.
So it is. Let's say there are two ways doing that. So the first way is the old school way, where the web design is deriving from the actual design space, print and media design. And the very first web designers were actually more designers than they were programmers, and they adopted HTML and using CSS. And today it is a little bit of a mix of that when you still have this approach. And you often have this if you have very unique websites, very artistic websites, very corporate identity, which isn't today the big case anymore. It was horrible 10 years ago when it comes to corporate identity. Today we have it way more loose, which is very good, to be honest. It simplifies things down. But this is the one thing. And the other opposing thing is to really create a system where you can't fail anymore. This is basically the design system, where you say, even if you are just a programmer and not a design person, you can use those things. So some design systems overdo, like MUI, for example. It is a very overdone one and very over-engineered one, and your apps basically explodes when you use that frameworks. It is sometimes even bad to run it on slow devices. Yeah, but if you're able to create a design system for you, this is the very first thing you should do, is to create a low-level design system for yourself, where, again, with the upper ceiling of complexity in mind, to make sure that those things can't happen anymore. So, for example, admin dashboards, they are a system. So if you have one page on an admin dashboard, it should behave like every other page in your admin dashboard. If you take a look at products or users, it is a list, then you have an editor, and you have several gadgets, components, widgets, column, however you want. But they should all behave in a system. And that is one of those points where you can actually do good things. But the problem is an admin area is not the same as the landing page of a new product, which shall, sell because of emotions. That's oftentimes when we work with Subway and other franchise systems a lot in the past, and they were very, very picky about the emotional side of things, right? And especially when you displayed those subs, those sandwiches, and the way how they are presented and displayed next to text was very complicated. So I think we should separate between those two things in the front-end development, first of all, and make sure that you reduce and this goes back to what Brian said. You are a big team. It's not just the front-end coder, the back-end coder, and a designer who is there for once in a while. No. The designers needs to be part of this process, as well as the back-end person and front-end person, in order to create a good product. Because you cannot just say, hey, the person who is running everything in Figma, talking with the clients, and never talk a word with the developers, and then come with a finished piece of, hey, this is the goal, but it's actually impossible to reach that in that quality. Then you have done something wrong before you actually set up the requirements well. And this is why we see so many successful applications today looking the very same. Look at right now, we are looking at StreamYard. It is, if you take a look at StreamYard, the header and the sidebar is looking the exact same like LinkedIn is. I have that above. It is the exact same thing. And the same with
the studio part looks exactly like YouTube Studio.
Yeah.
Well, I want to touch on the team culture thing that you kind of glossed over a little bit there. Is that so? In the case of my team, the designer is on my team, and if we're struggling with something, he's not so tied to his design. It's like, yeah, it looks good on paper, it looks good in Figma, very difficult to implement in reality. He's not so tied to the design because that he's unwilling to go, okay, well, what if we adjusted this over here to make it, easier to implement, easier to maintain. because he has empathy for what the actual construction might look like, versus I'm an artiste and I'm handing this off to another team to go and build.
I mean, to answer Hugh's question, I think one of the, at least a quality that I really admire in competent front-end devs is they are part designer. Like, they understand the intention behind certain graphical design decisions, and they understand how to tastefully navigate changes as they inevitably have to make changes to the design during implementation, right? So design has this waterfall problem of one person designs it to be pixel perfect. That's a plan, and it doesn't survive integration with, it doesn't survive being made concrete with something that exhibits behavior. I can make it concrete without behavior. I can make it a screenshot, I can put it on your screen, and it's going to be pixel perfect. But if you change anything, if you change the size of the screen, if you change the zoom level, even the DPI changes might change how it looks, right? So the moment it has behavior, that integration has to survive sort of grounding in reality with technology, with new things that the designer did not plan for, right? So that's the typical waterfall problem, and it lives in a completely micro ecosystem inside even the most agile project, if the relationship with the designer and the front-end engineer is such, right? So the most competent front-end devs I've seen is when the designer is thinking about wireframes and UX, and it's the front-end engineer who's thinking more about the design, right? So you have somebody who prepared a brand kit, there's somebody who's doing experience testing, right? So which is same thing as with the pen and paper and like the just checking out, does the flow make sense before I even go implement this? And then it's the front-end engineer who just yoinks the brand kit with the design system with the intended, wireframe, literally wiring it together, and then producing an artifact that performs well on all devices, right? And it's that wiring together and making sure it performs well that is their part of their competence, for which they can sort of express a high quality craft for, or maybe even engineering competence when they're also introducing like those subjective, emotional, and sort of more graphical design finesse to the engineering side.
And see, this
same thing with, for example, I had a plumber over, and you can tell some plumbers, they just know how pipes and gravity work.
Right.
But there are certain plumbers who understand the sort of the feeling of being in a home, and they say, oh no, your kitchen's over there. Usually it will be used in such a way that you would want it to be on the right-hand side and be triggered by the light switch. So you didn't ask for that, but I rewired your cabling a little bit, so that's a little bit more natural. So you don't have to think about it anymore when you enter the bathroom, right? So it's that aspect of, it's more than just the plumbing. It's the entire engineer.
Let's translate real quick to front-end design again. So, for example, I do that quite a lot. And so for example, you have a page where you have an API, a lot of data, and sometimes the API can be slower. Sometimes you are in a bad environment, like I'm in the morning sometimes sitting with my laptop next to the freezer and to the baking oven and all this kind of stuff. Magnetic fields everywhere, so the internet connection is bad, and APIs take longer to load. Now, this is normal. You need to take that into account. As a front-end engineer now, you are sitting in front of your overarching component, and you want to start to work on that one. The first thing I implement is actually the process of loading things and displaying the skeletons.
Yeah.
This is the very first thing you do, and then you work down to the button which proceeds maybe to the next page or something like that, and make sure this is working. Don't spend too much time on the design or do something like that. Make sure that the the outline of the page is convenient, because this is something which is basically, it costs you a lot to change that when you have finished the design. So don't start with the fancy things, because this is a tendency I see with a lot of front-end persons. They love to start with some form of animation because they just want to do an animation right now. That's fun to do.
Cool.
But programming is not fun, right? It is your work. It's engineering work. So the first thing you do is laying a good ground foundation and make sure that the page is actually fitting the non-functional requirements of the application, which is a good UX, a satisfying loading time, and all those kind of things. And you, for example, Lighthouse. We talked about Lighthouse. So first colorful paint, and the latest one. You need to take this into consideration when you start to build the page from the outline to the details, but not starting with the details.
Very difficult to test.
And this is a problem with Storybook, I see. Many people start to work on the details and suddenly implement API. This is a big problem in front end when this React pattern is so great, because it defines that you get data from higher order components and mutate data from detailed components, and that's actually great. But many people going into a Storybook component and then start to do everything inside there, so they want to have independent components. And this is, for example, one of those things. You can't do a very good user experience when your component, a button component, is fetching data from an API. And this data, it wasn't fetched by a higher order component, because you have a huge coupling problem. Because how do you actually get this information, if the API is pending or not, to a component on the other side? You start to do those weird things with your application state, and that is actually one of the things why so many UI developers are incompetent, in my opinion, because they don't understand the fundamentals, not from HTML in this case, or JavaScript. This is not what I mean. I mean from the idea of how should the outcome look like. So take this from transformational leadership, where you talk about the outcome and not about what to do next. And this is, I think, very important. What is the expectation? So a good front-end developer, as well as a back-end developer, of course, and everyone else, like the plumber, they should know why they are actually doing this. This is the engineering type, the bridge example, right? Why do we build the bridge?
This is the thing I rant about all the time, about how if you're a software engineer, you're a business expert solving business problems with code, not a coder. Great, you're a Java expert. Don't care. You're a commodity. I can replace you with a robot. I want somebody who knows how to solve problems. I want somebody on the front end who can make suggestions based on their experience to how we can make this work even better than the original sketch. I want someone on the back end saying, hey, what if we modified this flow? It would simplify the workflow of the person doing the job. This is what I try to do, and this is what I expect from my peers, is that you're not just coders, that you know the problem you're trying to solve. You don't want a plumber who doesn't care about the electrician, because they'll do all sorts of terrible things to your house.
Actually, here in Germany, you can get sued for that if you do it wrong. And you should be. This is actually some, but you should.
But don't worry, because in Germany, most of the plumbers don't work anywhere, because you can never get one, so it's never an issue.
Yeah, it's actually one of the big problems here with craftsmen in general.
I want to build a deck, so it's not that's.
I think it all comes down to the same idea. So if we want to do something right, we need to understand the fundamentals of the actual thing we want to do, understand why we want to do, right?
You can't find a competent plumber if you don't know what the outcome is, right? So you need to understand like what level of quality you're expecting in your home before you can even say that, I need someone who's.
There is something else I wanted to touch on, Adrian, that we were discussing before Dennis kicked us off and told us we should probably do it online, which is we were talking about you like to do end-to-end testing. And I was saying that we should really define what we mean by these terms before we're saying this is how I like to test. And
we did
full disclosure, Adrian's a much better front-end developer than I am. So I was pinging him like a week ago to ask him for some tips on how he does some testing things I was struggling with.
And Woody gave us a link as well for a Storybook sponsored post on it. So we had an episode a few weeks ago regarding testing, and I just had an episode about terminology, right? And I made it very explicit that I'm separating backend integration tests from front-end integration tests, because front-end integration tests have a different nature to them. I'm integrating something else. This Storybook article captures it, is that there are differences between the viewport problems and the browser problems, right? So the browser problems are integration problems. The viewport problems are not integration problems, right? So, but it doesn't use this terminology, sadly. And there's also, I like to use the term developer test for tests that you run while coding. That's sort of a unit test, but unit tests are a weird phrasing problem. The issue is that on the front end, most developer tests are using end-to-end tools to run developer tests.
Yeah.
Which is very, very unintuitive, because you might mistakenly think that what you're doing is building end-to-end tests. And if you make that assumption, you might actually widen the scope too much and make them useless and make them extremely brittle and fragile.
We actually had to go and create I worked and got a whole bunch of people who were passionate about testing from multiple business lines together, so we could create a Walmart testing glossary, just so we could stop having a 20-minute conversation about what do you mean by integration test before we could then start talking about how to improve testing. And so when I'm talking about an end-to-end test, I'm talking about I have at least two components crossing an API boundary talking to each other. So that could be a service, a database, it could be services, be front end to the service, right? And I avoid end-to-end tests at all costs, mostly. But I also focus most of my testing. I think, Adrian, you and I have a similar philosophy, I think, which is I try to focus most of my testing at flows, like multiple components inside, multiple. I do very little unit testing. It's mostly testing multiple functions together to verify.
You write an integration test where
that they work together.
Where there's a component to the test where it's an integration problem, but as you're running the integration tests, you accidentally, deliberately have to test some behavior as well. But as you're integrating, you're also testing against the behavior.
You get much more effective testing with much fewer tests, much faster. The only time I really dive into unit testing is when I have something that's relatively complicated at a unit level. That this function is relatively complicated. It's doing something very critical. I want to test this in isolation. Of course, then I'll also wire it into a flow. But you also, if you're doing that, you get a much better feel about what your the function level API is. Do you have a good method signature? Are things easy to wire to? And so I think it's really important. People underestimate how important test design is. And I know you guys have probably covered it as well, but I just can't leave a discussion like this without talking about how important designing good tests is.
Well, the goal is, there are for me two goals in testing, so to come to my mind. The first one is the confidence. So you want to change things with confidence. Often, like refactoring, or fast changes because something broke or something needs to be done until tomorrow, and you need to do that in the evening, and you want to be confident and go ahead, the idea of continuous delivery. And the other thing is that you still be able to move forward and not fixing tests all day long because they are too rigid for what you actually want to do. And this is one of those points I agree, especially when it comes to component tests and unit tests. They are often in the front-end space, especially component tests. If you don't write your components correctly, and you have a lot of tests, this is where people say, I don't want to test in the front-end world, right? Because you start to treat so you work majority of the time just on the tests, and you don't have the feeling to get to any output anymore. And the point is, what do you actually want to test, right? So you have two things, in my opinion. which needs to be tested in the front end if you want to have this effectively. One thing, or actually three things, sorry, but two things are very close together, like the unit test, where you actually just, in React, you just test a function or a method. This is just a very single thing. You have an input, you have an expected output, and maybe different expected outputs depending on the input. This is what you test.
Side effects depending on state, right? So you're controlling the state collaborator, maybe even mocking the state, and then you're figuring out how does it behave with this state, how does it change state if I do this, like
exactly.
This.
And then you have the component. In React, for example, we use Cypress to make component tests because components are already a little bit integrated. So they are not really like a unit test, but very close to it because the component is seen as a unit, but integrated. Integrated unit is a strange hybrid in this case. And there you need to... Right?
It's okay. No, it's not strange, right? It is an integration test because you need a browser. You need a very concrete implementation of an abstraction for the web API, and none of the web APIs are concrete. You need a browser. There's no such thing as an HTML browser. No, you have Chrome or Firefox. Or V8, WebKit, depending on which end of the spectrum you need. Maybe you just need the JavaScript bit, maybe you need the DOM bit, maybe you need both of them at the same time.
But there is now something in between, which is the big problem in all projects I was part in so far. And this is the layer in between your very small units, your components, and the actual overall behavior of the user experience. So the expectation or the happy path, call it like you want. For example, you have a flow, right? So a multi-stage flow you want to test. So you jump, you have some selection buttons, depending on the initial parameters, how you join the page for a business-to-business application,
for example. There's an API call in between.
Exactly, there's an API call, different data, you want to go next page, there you expect then things because of the input of the last page, so you have a state between those pages, and those kind of things. And your components are just testing their personal behavior. They are not testing what's actually happening in other components. And this is then
flow is rigid because it's
exactly, and the gap between then the actual test, which is then the end-to-end test, is the delicate thing you to do, because many people go and say, I don't need the component test, I put everything in the end-to-end test, and then you have this very detailed end-to-end test, which then you change something and they become very flaky because those tests take long, even though you can parallelize them these days if you have enough money for that. But it is still not really working so it is especially not working, as you said, as a developer test then. And this is the point. So end-to-end tests are then interesting if you only test the very outside things, so the very the minimum expectation of what happens. So you go to the first page with that parameters, and on the second one you expect this one, and the button must not be disabled but enabled, and click on the button. You expect this and not this to happen. Maybe you said you don't expect the toast to appear as a sign that there was no problem, but you don't test if the function which should catch this problem is actually working. This is definitely a part of the component then. And I think to get the right balance between those three types of tests in the front end is actually not easy. And very often I see that people say, I just do that with the end-to-end tests. It works in the beginning, but it actually cripples you during development, because then you say, TDD is not working because I do TDD solely with very complex end-to-end tests. Go ahead.
This is just the problem with all testing, is when people start, they really focus, their default is to test how instead of what, right? How did I get the toaster to pop up? Or how did I get this response from the API instead of what response did I get based off this input? That they default to white box testing. And,
but there is a distinction. I mean, Adrian has a point, right? So what you're describing is very isolated testing. So that is a very good example of isolated tests. The issue with the integration side on the front end is that there are multiple neighbors, which makes even what you would consider a unit test social, right? So it's not enough to just state test them. because I can state test it. I'm telling it, oh, I'm putting in this state, but maybe it's calling set timeout. Set timeout is not written in JavaScript. Set timeout is written in C++ and is part of the browser spec. So even just by me having access to that, I now have an integration problem. Set timeout is coming from like a really, really specific API, and now it's going to be different. Set timeout, it behaves slightly differently on every browser, and it's super annoying, right? So the guarantees that it gives are then an integration problem. Now the issue with that is that makes tests social, because I can't capture set timeout because I didn't specify it as an input, right? Which means I need to control the collaborator. I need to control the neighbor, right? The thing that makes it social, to be able to verify that behavior is still correct.
But this is what I'm saying is it's the same problem, right? And a test is an experiment. You always need to control your variables. You always need to know what their side effects are so you can eliminate the tests. Okay. And if you are focusing on the problem that I'm hearing from, we're starting to test, but then we're testing out the details. We're doing a white box end-to-end test. And the easiest way to kill any sort of dedication to testing is to write your tests in such a way that I have to constantly change them.
Yeah.
To get anything simple done. And that's just how you know you're testing wrong.
It's a coupling problem.
Yeah, but it all starts with so again, I told you the example in the beginning, how to start a component. This is the same with, let's say, organism component, like a page, right, in a React app. So when you start to work on this component, make sure that the overall idea of this component is very simple. So you fetch data. As soon as the data is there, the component will be displayed, and everything else should be part of the local state already. And this is often a misunderstood thing, that you need to do that like in the moment you click on something. No. Try to get that as soon as possible into your state, because it is very easy to use state in a testing environment, because state is just something as an input thing. So you can mock a state to every time. So if you reduce everything, which is actually the big power of something like React in this declarative way, where you actually say, I expect when I have this state, this out. So basically hypothesis and proof, and that makes it so powerful in comparison to the imperative way in the browser, where you do everything every time anew, because this is the very same thing with CSS and Tailwind. In Tailwind you see exactly at the component what happens. In CSS you need to take a look where is actually the origin from this imperative action or command right now. And if you consider that in the front-end architecture already, it's actually very easy to test it. So for example, you have a page with several buttons on it, and it's depending on the API call you do. So several calls, like asynchronously, and you get them all together, done in 200 milliseconds. You present the result. Maybe it's cached already for the next time. So it's basically instant there. And you have then a button which is not disabled anymore, and you can move on to the next one. So pretty simple, but you can overcomplicate this. Back to the question of you or Rage King, who asked, what is a competent front-end developer? If you mess up such an easy page, you are incompetent. Simply as that. Because you don't understand simple architecture, and the actual outcome, which is the good user experience.
The issue with front-end, the front-end, let's say, with the zeitgeist of just identifying as a front-end engineer, is that you are used to being in such a concrete world that you are heavily incentivized to only cover happy paths on the most concrete side of things, which is normal user flow in the most commonly used browser. You're just by operation incentivized to think that way, right? So you're not writing code and then running it on your machine in some like weird Dockerized Opera mobile browser that was hand compiled. No, you're probably doing it in Chrome because it's the industry standard, right? So there's the assumption that the user will be using some derivative of Chrome, or at least something built on WebKit, right? So that is not an accident. That is just front-end engineers sort of gravitating towards the sort of norm, the sort of standard, whatever it is, and they're super happy when there's only one dominant browser, which creates problems of its own.
You know what happens though is that as soon as they fail, suddenly they become a little less trusting of that environment. They start writing better tests, and this is one of the reasons why the whole concept of you build it, you run it is so important. Is because my team owns the outcomes of what we do, and so when something breaks, we take it personally and we try to figure out a way to make it not break again.
Never again. So how to the first thing when we get feedback, the engineers or myself, the first thing I do is express that in a test. Then the test is read, and then I work towards the solution. It is sometimes I'll even do that TDD aspect in the end-to-end test, where I say, okay, this should not happen anymore. So the end-to-end test can't pass right now because it's at the moment failing, but it will never again fail in the very same way. And that's actually a part of the confidence building as well. I have to say, I really like that approach. It's not as easy as on the back end, because
Why?
most tests will be social. So that's actually a very difficult. I mean, I've spent most of my career just analyzing these trends. Like, why is testing on front end so much more difficult? It's because I would like to respond to that, because I only test in Chrome, and it works fine on all browsers. As I said, only one incident. The point is, let me finish. Let me finish.
Yeah.
So there is a social aspect to the tests, which is, if I write code, if I didn't write my CSS, I will assume I don't have to test anything visual. But that is my backend brain working. But that is not correct, because I can have CSS at 0 elements, right? And I now need 0 tests, because there's nothing to display.
I have a concrete example of this problem. This bit is going back to zarf.dev and that animation. That animation was originally done in JavaScript. It's now done in CSS. And when it was done in JavaScript, if you brought it up on Chrome, it looked fine because we were doing most of our validation in Chrome. If you brought it up in Firefox, it looked like speed. It was running at a much faster clock rate. And if you brought it up in a browser on your phone, it would be incredibly impactful to the responsiveness of the page.
Yes.
Right. And so we re-implemented all of that in CSS, and that eliminated the problem.
Yes.
Right. So yeah, we do most of our validation in Chrome, but I'm far less trusting than I used to be.
Yes.
When I was doing internal development for Walmart, we only used Chrome. There were some things that some other areas did where they were using, I forget now. I'm blanking on Microsoft's old browser name. But or Firefox, people be using other things, but for the stuff we were doing is like the people only had Chrome. We only had to test in Chrome. And so going back to this, that's just the default. So I'm just going to test in Chrome and it's fine.
Yeah.
Right. But I'm far less trusting. And so now I'm actively seeking tools to make it easier for me to get automated feedback about cross-browser validation of some of the behaviors, cross-browser validation, like the thing with Chromatic. I want to do visual testing. Is it rendering the way that it was supposed to be rendering?
Get different viewports, different browsers, combinations.
Does it visually look like it should?
Yeah.
And I can't, before I would just use Jest and validate the DOM. I'm far less trusting.
Yeah.
The point is another one. So maybe it's coming from the backend area where we say, hey, as long as the tests are running, we can code everything and it's fine. It is not applying to the frontend area. It is not. This is one of the criteria. We talked about that beforehand, that you need to understand design, you need to understand the quirks. So in frontend, it's very important to get the, let's say, HTML's CSS part right in the beginning. They won't change every day. So the problem with those testing things is that it is extremely expensive to test those things and not very reliable, because you can't cover them all. So you have Samsung browser on Android as a standard browser, not Chrome. It is totally different than Chrome. There's so much different behavior in that. Good luck testing that. So what you need to make sure is, again, to build something which is not prone to break. This is what I meant in the entire conversation, actually, which I mean exactly with the upper ceiling of complexity. If you surpass this ceiling, actually, you get into problems. So we are talking quite a lot about an animation. And animation is by default over-engineering. It is not necessary to fulfill your business goals. It is just there because someone think it looks nice and people want to identify with that, a little bit like a mascot. Maybe that's animation is important, but it is over engineering.
It's there for emotional impact. It's not there to
so then treat it differently. So if it behaves a little different in a browser for 2 days before someone sees that and reports, then it's okay. Then it's basically a regression acceptable. But if you say that this animation must be perfect on every browser to every time, you have decided that the quality is on a level which is and will be hard to test. But what I mean by we only do it Chrome, because the animations we use are reducing down to what Tailwind offers, which is animate spin, animate pulse. That's actually it already. And those are actually working fine. We don't need more than that.
And we have examples of this. The Apple.com website is notorious for having fanatically handcrafted, animated experiences through a web page that is not an application. It's a catalog, but the experience of navigating the web page is immaculately crafted, and it only works well in Safari.
Yeah, so let me give you a counter to that.
And it's using non-standard APIs to get that performance.
Let me give you a counter to that. When I go to a page like apple.com, I'm there for a very specific reason, and to look at their carefully crafted, beautiful animation.
And the e-commerce part of that website is fugly. It's completely functional. Same as on Amazon, right? So the team that does the e-commerce part is completely separate from the animation space.
I was there this morning looking at pricing out an iPad Pro 11.
Yeah.
And I was not enjoying the experience. I will just say that.
No, and I mean the experience on the e-commerce side is subpar compared to those animated landing pages, right? So that's I agree with that.
Literally, the only reason the page exists is to sell devices.
Yeah. No, but my point is, there's one page meant to delight, and then there's a completely separate page curated by a completely separate team, built to perform a function, which is go through checkout, right? So one of the web pages had a critical requirement for delight, which is aesthetics and animation, and there's a separate page which goes hand in hand with this one, and it just had functional requirements, and then following the brand kit on everything else. That one, I wouldn't imagine anybody would test the look and feel of it. Whereas with the landing page, the only thing they will be testing is look and feel, right? So this is part of the testing strategy. Somebody has to come in and say, in this part, we are testing look and feel like crazy, and we're going to automate that because it's very difficult to replicate everything. And on the other sides, we're going to test look and feel once on like a broad stroke with a design system. We'll have a brand kit, and we'll just make sure that our designer talks to the front-end engineers to make sure all the brand kit UI elements are viable to some degree and accessible. And then whichever product engineer who's full stack or semi-front, semi-back, whatever they are, they can then use it. And then that's going to be part of our engineering culture. That's where we put our architects, our coaches, our staff engineers to then create the developer experience necessary to get the brand kit in as many hands as possible, because that's scalable. But the delightful animation page, that requires a specialist. Like that requires the equivalent of a movie producer, not a somebody who's very good technically with moving a camera around.
Yeah,
and so
it just irritates me, which is why I'm probably, I'm very functional when I build things. So that's why I'm not a good designer.
But on the aspect of, there is differences between backend and frontend. I just want to highlight that it is the same ecosystem. It is still code. It's just that the way we interface with them is there are global variables, essentially. UIs have global variables. The browser API is a global variable. That's what makes it difficult, right? So the user land code does not run in backend.
You don't know your interpreter yet. This is the problem.
Exactly. In the backend code, your if statements don't change depending on the color of your interpreter.
Mm-hmm.
In the front end, they do, right? Because the color of your interpreter changes how the API operates. And on the back end, user land code runs first, and then you integrate with the kernel, you integrate with the system. On the front end, it's the other way around. You deploy your code to an already living integration point, and then it runs you, giving you the illusion that you're in control. Right? Because you can run JavaScript code in a browser, and I can switch to a different tab, and now my browser takes over and tells you to shut up, and tells you to, no, you don't have access anymore. You're suspended.
Now, I will say
there might still be audio, but it can't refresh. It can't re-render.
I'll say that it's very similar to the experience I had for most of my career, because for most of my career I was not deploying to a known environment. I was deploying to a PA, an HP PA risk system that was handcrafted. I was deploying to a whole bunch.
Hey, what's up, Brian?
Of HPPA risk systems that were handcrafted by an infrastructure team with no version control, and every single one of them was a special snowflake. So it's actually worse than deploying to Chrome or Firefox or.
But again, we need to come back to the point that I can't stress that enough, right? Try to do at least as possible. So we already tackled the problem with CSS these days because many of the problems in the past came from the cascading aspect. But now, if you just use Flexbox, grid, positioning, a little bit of coloring, and you try to use those little tools just to get the things done, maybe with breakpoints, and you don't try to use anything else before you can't get to the actual goal, then you're actually the quite safe way, because those things are very compatible across the browsers these days, right?
What I say earlier is that if you're an expert at Git, you're probably using Git incorrectly. If you're an expert at CSS, you're probably using CSS incorrectly. I mean, if you're not having to Google Git commands or Google CSS stuff for things that are edge case, then you're probably doing it wrong because you're using too much of the framework.
Too much finesse. Yeah. Too much. It's not good to have too much finesse. Yeah.
Yeah. Especially CSS. When people say, "Oh, there is a new freaking awesome selector inside there, you can do so great." I think to myself,
if you add,
I don't use them at all.
Yeah, if you add an ID and a class, it takes slightly higher priority on precedence, so I can have a case.
Forget that. This is doesn't make sense. This is poor quality coding, and you think you are a great craftsman because you all understand those little things CSS can do. Why?
Yeah. Everybody.
Why?
Before people start focusing on how cool it is, they need to focus on.
Yeah.
I'm a business person, and I'm in operations. And is this new thing going to add business value that offsets the operational support costs of doing it before I go and do this thing? Right?
Yeah.
Now there's what you just said used to mean just use standards, use the standard tools. But there's a problem. There's a slight problem on the front end in that a lot of times the best solution is not the standard one.
No,
a lot of times there are.
But there's a big difference between what I'm saying and saying just use standards. I'm saying that we need to have a business reason for doing things, and it can't be, wouldn't this be cool? That if the thing that we're doing will cause an emotional on the front end, will cause an emotional impact, it will keep people engaged on the page. If we expect, and we should test for this as much as possible, if we expect that adding this complexity will drive people to use our thing, then it's valuable. Even if it adds operational cost, there has to be an offsetting value, right? But if we're doing it because wouldn't this be cool, then we're adding ongoing support costs. We're tying ourselves into a visual API that's very hard to change. People are like, well, it's already there. Why would you take it away? And it's not providing any value. We have to be very careful about these things. And to your point, Adrian, it's like keep things as simple as possible. Don't be clever.
Discipline comes to my mind. I think
be disciplined. Solve the business problem. Try to get people engaged with the least amount of cost and ongoing operational expense possible.
Try to ask a developer. I have done that once because I'm an employee, so I pay for the stuff actually. And sometimes when people add too much stuff, I ask, okay, if you want to deploy that, you need to pay personally for the expenses of those new functions you have just created. Oh no, I don't want to. Okay, then please.
Oh my God! And so on that team when we were first using Angular and building our very first web applications for the distribution centers, somebody added animation to an icon so it would like spin when you clicked it. And I'm like, is this going to help them get their job done better? Or was this just because you thought it was cool? Right? And so that animation went away. It was literally just because, wouldn't this be cool? Because CSS. No, stop it. If it doesn't help do their work, if it doesn't make it easier to use, stop it.
You can do art in your free time. That's actually a hobby. What you do is engineering, make it as resilient as possible, because every animation can cause problems in other browsers. And that is what we're talking about. So why shall we test every little edge case, corner case, circumstance, possible opportunity somewhere, if we could just leave it out and don't need to test it at all? And if we take a look at what is really standard in CSS, in HTML, and reduce it, so let's say not the standard which is written somewhere on a specification page. I mean the industry standards. I mean those standards which actually are applied and they are working, right? And those kind of things, I mean, if you reduce yourself down to those, as I said, Flexbox is working, positioning is working, colors are working, fonts are quite working, and if you don't do too much shitty fancy stuff there, you are actually quite safe. So as I said, we only had one incident that a div was a little bit shorter than it should be, but it still was working. And that is actually something I don't create a complete test suite for, because it is not worth it.
I want to be very, very clear. I'm not talking about just use standards, go out there and pull down some sort of UI framework and and be boring. It's like there's a few different websites we have, and we have some different buttons on each one. And I prefer the button that's animated as a user. I prefer the one that when I hover it over it, it creates an arrow and it feels like it makes me want to click it. Right? Versus just I'm going over a button and it changes color and I click it, right? It like makes me feel like I want to click it. And so you have to, don't do things because they're fun to you. Do things because they're fun to the user.
That's a good point.
Coming back to this idea that we discussed earlier about back pressure, with the example that we started off on, Brian, regarding, how much right code do you have? What do you need to test?
Yeah.
What's tests, as a theory, academically speaking, just looking at the qualities of the tests and different shapes of tests, it's very easy to keep the whole ecosystem very disciplined if you could decompose the important bits correctly. And that's the most difficult challenge with testing. It's just decomposing the right behavior.
Oh yeah, I'm trying to do that right now. This
is an animation. What I care about is how long it takes to run, because that's going to give me a good estimate for tick time in all browsers. I'm not going to test what the animation looks like because we might change it. We might change some details on it. So I don't want to have a silly test to check that this animation looks similar to this GIF, because I might be losing some important detail there. And that's an unnecessary end-to-end regression test. What is important, however, is this ability to say, look, there's a form. If there's a form and the user has to go forward, there should only be one button there should be exactly one button which signifies that action. So us as developers, we should be able to introduce architecture into the system that allows us to define and find that button. Right? So and that architecture doesn't make sense, and it slows down the production code outside of the context of testing. So if you don't have an engineering culture of like high testing standards, then you'll be looking at it from the lens of, oh, that's extra steps on the front end. It's just going to slow down rendering speed. It's just going to, it's just going to make my Lighthouse score go down. That extra level of extraction is going to make my Lighthouse score go down. So the challenge is figuring out, okay, which of these are extremely important for the business to introduce extractions to them, but then the testing can be simply decomposed. So I can say, as a form flow, there should always be a submit button that drives the user forward. If the submit button is missing, there should be something in the page that says, something's wrong, I'm going to reload the page. Facebook does this, by the way, right? Because they canary deploys randomly with user testing. And when there's an issue, if you can't see the feed, the production code, their observability systems will notice that this user does not see the feed anymore. And that's not okay. And it's going to trigger, this is a problem, you should probably reload the page.
Right? Yeah, so this is why it's called engineering, is because it's all about compromise.
Yes, exactly. Because
it's just like logging on the back end. The act of logging slows down the performance of the back end. If you don't
That's
have
a good example. Yes, that's a very good example. Right. Or the fact that if you're logging, the log itself might not be buffered like it is in most languages, which means that if you're logging too much console output, if the console is not buffered, if your connection to the console is not buffered, you're actually
50 megabytes of string you log 10 times in a row because React is rendering.
Because a lot of languages don't have asynchronous loggers, right? And that's, hello PHP guys, you probably don't even know this is a problem. So, right? So there's this whole aspect about most of what we are talking about as good practice, as a high standard for high performing tiers, will look like bad recommendations for a team that has very bad testing habits. Because it only makes sense in the context of, like, it's really important that mission critical stuff to the business is test covered. Because we want to be able to move forward quickly on it, right? So if the requirements change, one thing can break, right? If I change my mind on the animation, I'm okay with one test for the animation breaking. What I'm not okay with is all end-to-end tests breaking. Because all end-to-end tests had that condition of, wait for the animation to finish and then click the button. If I change the animation now all the tests fail. And the issue is, that's good once, but now the team no longer.
This is what my example in the beginning, that you have a proceed button, for example, on the page, and you control the end-to-end test by this button. So if this button is not disabled, you can't proceed. This is a good example that it is a smoke test anyway. You don't want to know what exactly happens on the page. You need to investigate or take a look at the unit tests or try to find out, but you want to know that it is not working. Right? And if you have too many steps in between and you wait for too many things in between, it becomes flaky. For example, flakiness can be reduced with things like 10-stack query, where you just say that, hey, if an API is not responding in time or is actually breaking, you reload the page and you give the test a little bit of time. This is all you want to know. You always need to consider those things into anyway. So you can't say, I only accept 50 milliseconds of loading time of an API, because for most use cases this is not necessary and makes your tests bad, and the overall experience is even anyway bad if you are in a bad environment with your Wi-Fi, for example. So make sure that the business value is covered as well as your capability to actually move forward and do those refactorings, for example, or new changes, new features. Because first of all, if you have too rigid tests or too complex tests, you can't do because you fix and test all day long. But if you have too less tests, you will get too many responses of clients, of upset clients, that things are not working anymore. So finding the best middle ground is actually what makes modern front-end engineering so, I think, a discipline. So you need to have, how do you, as we said, if we need to wrap up a little bit, is like, how do you implement the correct designs, make sure it is on all browsers the same, it is working in the happy path, it's decent in speed, in a good user experience, and at the same time it's well engineered and maintainable, so non-functional requirements. This is what makes this discipline so unique today. So it is, of course, very similar to the backend one in many cases, but very different at the same time.
It's
and
really not looking at private chat. Brian has a hard stop.
Oh, yeah. Actually, me too.
Sorry.
So that was actually a wrap up, I would say. Sorry, that Brian. Any last words?
I mean, front-end development's not easy if you're a back-end developer. If you say it's easy, I double dog dare you to do something more than just throw a couple of divs together with a table or something. Build something real that someone actually wants to use, and I just dare you. If you're a front-end developer, since testing is worthwhile, grow up. It's absolutely required if you're an actual developer and not just a code monkey. I really want better tools to verify that I didn't cause some sort of visual regression that's not.
There are very good tools, right? So
if you know of really good tools to help me fix the problem of visual regression, div overflow,
Cypress, Playwright, and Storybook are industry standard tools.
Yeah,
and everybody will tell you not to use them because they are end-to-end testing tools. And the problems that arise from using them is if you're using them to write end-to-end tests. They are being marketed as end-to-end testing tools, but the best thing you can do with them is to write integration tests or even developer tests.
Yeah, I'm using a Storybook right now and trying to integrate the other tool I told you about for visual testing. But I need Chromatic, but I really need my pipeline to break because I now have a div overflow that I didn't see because we didn't sit there and play with the responsiveness of the thing. But anyway, I do need to run. I love talking to you guys. It's always a lot of fun.
It's great having you.
Likewise. Thanks. And yeah,
until next time.
So yep. Dennis, any last words from your side?
I just wanted to mention this exactly that I said to Brian now, which is, end-to-end testing gets a bad rap. Most of the enterprise and sort of expensive but very capable tools are being presented and marketed as end-to-end testing tools, which I think is a shame. So please use them, but don't use them to write end-to-end tests. Cypress is amazing. Phantom.js is amazing still. 20 years later, 15 years later. Headless browser testing. You can get a real browser running up in a Docker container. Use it, right? So Phantom.js, Cypress. You can skip Selenium. Selenium is a little bit too old school. You can use Playwright. You can use Storybook. Just please don't do the crazy end-to-end, like combinatorially complex discovery of the entire problem space of I have 10 components, there's 5,000 different ways to combine them, so I obviously need 5,000 different end-to-end tests to test everything that I need to make sure that it all works correctly. And then that means 40 different viewports, 20 different browsers. Oh, so I have 1 million end-to-end tests running right now, and it's going to take 7 hours to complete. Like, just don't do that part. The tools are great. Just write as little end-to-end tests as possible. That would be my advice.
So good. I would say we'll wrap up today. Yep.
Yeah.
So thank you, everyone, and see you tomorrow.
Yes,
Dennis?
Tomorrow at 1 p.m. Central European Central Time. We're looking at data-driven engineering management. I became a top mentor on Mentor Cruise. I've been coaching a lot of engineering leaders, and I want to share some tidbits that's repeatable and reproducible by others with a few easy steps and a little bit of discipline. So we're gonna basically have a little mini case study from what I picked up in the last few years of coaching engineering leaders.
Mm-hmm. Good. Then I would say see you and have a nice evening, everyone. Thank you, Brian. Thank you, Dennis.
Yeah, thank you.
Thank you, Brian. Until next time.
what is actually well-being then for software professionals? So why are we going to talk about that? Richard, can you take the word and talk a little bit about your experience and why this is a big topic we should all take care of?
Yeah, so I think, interestingly for me, I've always been physically active. So well-being used to mean to me just physical health, right? And so I've always thought, yeah, I've got that down. I've always gone to the gym. I've played football. I've played squash. I've done running. So that's always been something that's there. And actually, only later in my career did I realize how much that was helping me along the way. But I wasn't doing it deliberately. I wasn't doing it for that purpose. And I hadn't connected the dots. Reflecting more on my career and some of my challenges and trying to piece it all together, and thinking a bit more about the mindset, about mental health and all of that kind of stuff, I realized well-being is much broader than just your physical health. And I think one of the biggest and most interesting things about well-being is that it's very individualistic. And so that is, it's good and it's bad in a sense, because the fact that it's so individualistic means that we can't just put a single label on it. So we can't say to everyone, this is well-being and you've got it or you don't. And so for some people that's hard and it's complicated. On the flip side, it's actually really good for us because well-being means different things to different people, and we decide what being means to us. And that's super important, and it touches, it's very closely linked to a big part of what we're talking about here, which is responsibility. And almost the first part of our responsibility is to define and to recognize what being means to us. And so just broad stroke, that's your physical health, your mental health, feeling safe in the environment that you find yourself in, and feeling safe being social with people as well. And yeah, that's a broad thing, and those different things mean different things to different people, and it's finding your mix of those and then branching out to the things that contribute positively to them, which can also be completely different for different people. So suddenly everything's thrown legs, and it's huge.